Okay, hello Math 085 students. As I mentioned, of course, we'll be turning our attention to online learning for the time being. Just like in the other class, I'll be creating several YouTube videos going over the notes that I posted to Blackboard for you. So we'll get right to it. These are, this is the topic 5 worksheet, Essentials and Basics for 4.3, 4.4, and 4.5. Problem 1, we're using synthetic division or long division to divide here, and we want to write our expression or our answer as an expression involving x. Now this is the form that I had wanted in the if we were in class, but the book was doing things a little different, where they were going to multiply both sides of this equation to clear out the fractional form. In other words, the form that like my math lab will want here is it's going to be dividend equals quotient times divisor and then plus the remainder. So just make sure that you're paying attention to the form that my math lab wants the answers written in. So in this problem, I've got I guess I'm showing you two options here. Here's the long division process. I have this at the end of the notes on Blackboard, the expression that is in the denominator always goes outside the division bar. The expression that is in the numerator is always going to go underneath the division bar. Make sure that you've got those arranged correctly. So then when we divide, we want to think of a number, or a term such that when we multiply by x minus 3, the leading term is 4x cubed. Well, if I take 4x squared times x plus 3, I get 4x cubed minus 12x squared, so the leading terms are going to match. I then want to subtract these expressions. That way the leading terms are gone. 4x cubed minus 4x cubed is 0. Negative 14x squared plus 12x squared is negative 2x squared. And then you can bring down these other two terms here. So then I want to think of another expression such that when I multiply by x minus 3, the leading term would be a negative 2x squared. Well, if I take negative 2x times x minus 3, I get negative 2x squared plus 6x, so those leading terms match. Again, I want to subtract. Probably the most common mistake that I'll see students make is that they won't be subtracting. Be sure that you subtract here. Negative 2x squared plus 2x squared is 0. 5x minus 6x is negative x. You can bring down the plus 11 and divide one more time, it looks like. So if we think of an expression such that when we multiply by x minus 3, the leading term is a negative x, we're going to want a minus 1 there at the end, because negative 1 times x minus 3 is negative x plus 3. Those leading terms match. Again, we're subtracting. Negative x plus x is 0. 11 minus 3 is 8, so 8 would be my remainder. Now, in this form, you always have the quotient plus remainder over divisor, so I'd want to tack on 8 over x minus 3 if my answer were to be written this way, and that's what I have circled here. Here is also the synthetic division process. So 3 is the 0 of the denominator, therefore I'd want 3 to be in the upper left-hand corner of this table. The top row is just where I'm picking off the coefficients in the numerator, so I've got a 4 in front of x cubed, a negative 14 in front of x squared, a 5 in front of x, and an 11 at the end. You can bring the 4 down, and then 4 times 3 is 12. When you add the next column, you get negative 2. Negative 2 times 3 is negative 6. When you add the next column, you get negative 1. Negative 1 times 3 is negative 3, and then when you add the last column, you get 8. So it's a continual process of taking the new number times the number out here and putting that in the next column and then adding the next column. This bottom row here allows me to, again, to get my answer in terms of x. So 4x squared minus 2x minus 1 plus 8 over x minus 3. That's exactly what I had when I went through the long division process. Make sure that you know both synthetic division and long division. Remember, you can only use synthetic division if you're dividing by a binomial. So sometimes our only option is to use long division. Okay, problem 2. We want to check if these two numbers, negative 2 and 3, are zeros of the function f of x. Then use the factor theorem to decide if x minus k is a factor of f of x for the given k value. Remember that if k is a 0, then x minus k would be a factor. Okay, so if I plug in negative 2 into the function, I end up getting 0 when I simplify. And so that tells me that negative 2 is a 0 of f. A 0 is a number that's going to return 0. And since negative 2 is a 0, x minus negative 2, or x plus 2, that's the same thing, would be a factor of f. Okay, and so that would be helpful, you know, if I were going to begin factoring, I would already know one of the factors here. 3 would not be a 0, since when you plug in 3 into the function, you end up getting 20, and therefore x minus 3 would not be a factor of f. Okay, so there's a connection between zeros and factors for these sections that we'll be using in a lot of the problems. Problem 3, the graph of a polynomial function, f of x, with leading coefficient 1 in integer zeros is shown in the figure. Write f of x in complete factored form. Okay, so a 0 is the same as an x-intercept, which means that in this problem, all I need to do is identify the x-intercepts, and those numbers would be my k values. If k is a 0, x minus k is a factor. So knowing that negative 5 is an x-intercept, and also therefore a 0, x minus negative 5, or x plus 5, would be a factor. Negative 2 is also a 0, so x minus negative 2, or x plus 2, would be another factor. 2 is the third 0, so x minus 2 would be the third factor. Now, a equals 1 just simply means that I would have a 1 in front of all three of these factors. Sometimes a will be a different number and sometimes not. Okay. Here they're just telling us let that leading coefficient be 1. Problem 4 is a similar problem, only this time we're going to let a be negative 3. So the negative 3 would just kind of act as a multiplier, and the problem would be handled the same way as the last one was. I would just simply identify the x-intercepts, and then I would know the zeros, and that would allow me to be able to write these factors here. Negative 3 is a 0, so x minus negative 3 would be a factor. Negative 1 is a 0, so x minus negative 1 would be a factor. 1 is a 0, so x minus 1 would be a factor. And then 2 is a 0, so x minus 2 would be a factor. And we're just leaving our answer in complete factored form here. Sometimes they'll want you to simplify this and sometimes not, so again, make sure that you're reading the directions for how the answer should be written. Okay, we'll stop right there.